a teacher in the 10th grade, my chemistry teacher, Mr. Jaber, who was Syrian, took me aside and showed me some chemistry and showed me how to make nylon out of a couple chemicals in my class when I was in the 10th grade. And I didn't realize it then, but 40 years later, when I look back, I've had a very successful life. Every bit of it was because of that interaction with that teacher who does this to kids all day long, who does it to all of his students. But my entire life went from this direction, which would lead to construction work, Waffle House, babies, yada yada, to this direction, which has led to being the director of the world's largest astronomy outreach program and numerous educational and professional titles and all that kind of stuff. But had it not been for that guy caring about me, who knows what would have happened. So when I had a friend, well, I went through a bunch of astrophysics and mathematics at various colleges. I got lots of fancy titles, we'll just move on. I spent my youth after high school in the Navy on a submarine learning nuclear propulsion. I was an engineer on a Navy nuclear sub. And when I got done with that, I got out and became an air traffic controller for one reason only, and that's because of the money. My education, I could have done various things. I wanted to be a math teacher, but $200,000 a year in 1989 was pretty hard to turn down. And so I became an air traffic controller. And it's a great paying job, and they are desperately looking for people, if any of you have an interest in that job. So I did that, and I retired from both the Navy and air traffic control last year. Naval Reserves about 15 years ago. My inspirations, well, you guys are too young to even know what we're talking about anymore, but Gene Roddenberry in Star Trek was a big inspiration on me as a kid, and Carl Sagan. Carl Sagan is who actually wrote all the stuff that Neil deGrasse Tyson is taking credit for now. So he was the first major public astronomy outreach person and science outreach person in the U.S. And when I was a kid, this same science teacher got me a spot. Look how handsome I am. That's what kids look like back in 1981, so I feel lucky that you don't have to look like that. I went to a class at Georgia Southern in the 10th and 11th grade years. I won this competition, and I went there. And Carl Sagan was the instructor. This is 1981. His book Cosmos was at its full swing. The PBS production was there. Okay, it's doing something funny. Yeah. And this guy, the most famous scientist in the world, took 6 weeks out of his summer at no pay, no charge, nothing. He came down to Georgia Southern College and taught us about chemistry and computer science. That's a big deal. These guys that work here, these professors, are not here for the money, if you haven't noticed that yet. And I know most of you come from fairly well-off families and are doing okay. But even then, these guys are here because they care about their society and their community, and they care about your future, and that's why they're here. So that had a profound impact on me as a young kid, and allowed me to become very successful in life. So this is the lecture I give. Ever since then, I've had a pretty normal life, as you can see. This is the lecture I give to astronomy conventions or colleges around the world when I tour during the summer. I go around the world and help people set up their own version of this program. So this is a pretty generic lecture. Take what you want from it. That's fine. Yeah, that's Natalie. She straightened everything out. That was before Natalie. That was my brief stint with New York City when I lived there. I was in a metal band for a while. Yeah, it's all the same stuff everybody does. When you get to be 50 years old or older, you will look back, hopefully, on a very rich life of very unusual things. And I say, do not let an opportunity pass you by. Do not be scared of anything, and do not be fearful of failure at anything. Just look at the people around you that are already doing it. If you don't think you can do something, you're wrong. The only thing stopping you from doing everything is the fear. I learned that in boot camp and when I worked with Marine Corps for a while. The sun, I asked this question to about 80,000 kids a year in Georgia, and another 100,000 or so in foreign countries. In Georgia, I have yet to have a single student or teacher be able to tell me what the sun is made of or how it works in 8 years. Okay. That's the state of education right now. In Tunisia, Libya, Algeria, Israel, Lebanon, all over Australia, Philippines, India, I've never had a class yet where someone did not know what the sun was made of and how it worked. And these are 5th and 6th graders. Okay. Does anybody here know what the sun's made of?
Come on, guys.
It's nuclear fusion.
That's the process that powers the sun.
Helium?
25% helium. Anybody else got a guess? I'll give you a hint. It's the most common element in the universe.
Hydrogen.
Water is not an element. What? Who said it? Who said it?
Hydrogen.
Hydrogen is correct. Okay? And don't be ashamed. Listen, times have passed now. People, when I was your age, everybody wanted to be an astronaut. Everybody wanted to be a scientist. Everybody. There was no doubt about it. Okay? We all wanted to be on Mars or the moon. Everybody. Nobody cared about, I want to be rich. The whole I want to be rich phenomenon is your generation and the one or two before it. And I can tell you right now, money is completely irrelevant in your life, as long as you have a certain amount of it or higher. It changed from, I want to change the world and be a scientist, to where's my money and what's for dinner. That's what's going on nowadays in the U.S. Okay? And I don't want you to go that route, because you will be miserable if you chase money. Okay? You should chase what you love. The sun is made out of 75% hydrogen atoms. The sun works by gravitational collapse. Every star in the universe works the same way, by the way. Gravitational collapse of hydrogen. And when you add pressure to a closed system, the temperature goes up, right? It's directly proportional. At a certain temperature, 15 million degrees Celsius, the hydrogen fuses into helium. And in that process, energy and light is released. That's why you're alive. That's why everything on this planet is alive. Every living thing you've ever seen or ever known or ever will know is alive because of that star up there that uses this process. Now, the proton-proton cycle is a little more complicated, but you can look a bit more into that if you want to. A bunch of protons get together, make some helium, release photons, gamma rays, and neutrinos. You are bathed in solar wind 24 hours a day. Okay? We live in it, we evolved in it. This is your address. Your address may be Thailand, your address may be Atlanta, Georgia, USA, but you should continue that address with the solar system. This is where you live. Milky Way galaxy, universe. Okay, because that's the future. I mean, you guys will be, within your lifetime, probably going back and forth to the moon or Mars or perhaps Europa. That's coming, that's the future. And I want you to do it. Okay, sitting on the couch, watching TV, is not going to cut it. This is what's coming, I can promise you. Because when he and I were young kids, none of this stuff existed, man. We couldn't have told you what was coming to save our lives. Now I've got a device in my pocket. I can research every piece of knowledge ever attained by mankind in less than 5 seconds. That didn't exist in those days. So this is what's coming. This is shot from my balcony where I live in Virginia Highlands with my wife. I walk down the belt line. You guys know where the belt line is? I walk down the belt line every day with my dog. And I can count on one hand how many times I've ever seen anyone look up in the sky. And every day there's this beautiful sunrise on the belt line and sunset. And this thing is just a massive glowing ball of hydrogen fusion going on right above our heads. It's unbelievable. Imagine what Stone Age man thought when he looked up and saw that. You know, that's where religion comes from. You know, it scared them, so it must be a powerful God. Let's make a monotheistic religion and worship the sun. That's how it all started. Today, who cares? You know, everybody just walks around and they do this. Hey, meet me at the mall. Hey, did you see that dress that Susan was wearing last night? Okay, just, man, this is a communication device only. This is not for you to live your life on. All right? So, you know, dump it. This is what it looks like in the sky. I find that absolutely amazing every time I look at it. The field that I teach is called solar spectroscopy, and there's some laws called Kirchoff's laws. Anyone here know what I'm talking about? Ever heard of any of this? Okay, it's very simple. The sun produces energy via nuclear fusion. The core of the sun is the only place that occurs, about 15% of the mass of the sun. Everything else, all the way to Earth, is just that energy cooling down. Okay? So the convective, the layers outside of the core, all the way to the photosphere, to the chromosphere, to the corona, it's all that energy just dissipating and reducing its heat. Now in the corona, it gets hot again for electromagnetic reasons, but basically, it's just dissipating. At the point where it becomes transparent to visible light, we call that the photosphere. That's what everybody thinks the surface of the sun is. There's no surface of the sun. Okay, it's a gas. It's a gaseous body. So there's not actually any surface. But when it becomes transparent to visible light, something else happens. The visible light leaves the sun and it enters the chromosphere. Okay, so you've got this super hot incandescent body. Anybody know what incandescence means? Okay, incandescence is if I take your head and heat it to 700 degrees Celsius or higher, you will begin to emit visible light. Incandescence means anything you heat to a certain temperature or higher, you will emit light. You ever seen lava? Lava emits the lowest energy light wave on the spectrum because it's near the lowest temperature required to emit visible light. The hotter it gets, the more portions of the visible spectrum it emits. That's what incandescence is. An incandescent light is made out of a tungsten filament that's heated to 1500 degrees Celsius and emits visible light. That's how it works. The sun is an incandescent body. When that energy leaves the photosphere of the sun, it is hot. It is a continuous spectrum of visible light with no breaks, just like a rainbow in the sky. When it enters the chromosphere of the sun, which is a gaseous atmosphere that's around the sun, the chromosphere acts as the gas cloud there. The light source, the sun, gives you a uniform spectrum with no breaks right here. When that light goes through a cooler gas, it emits the visible spectrum minus whatever elements are in this cloud and what wavelengths they absorb. Hydrogen absorbs a certain wavelength when you run light through it. So that line is like a UPC code for hydrogen. There's several hundred other ones in the spectrum, but this is very simplified. So if you pass hot energy through a cool gas, you get absorption lines in the spectrum. If there's no light source and it's just the gas cloud that is energized, like a emission nebula in the sky, like the Orion Nebula, well, that's a reflective one, but you get the idea. Then you get an emission line without the continuous spectrum. So the light source causes this, the absorption causes that, and without the light source you get this. In the sun you have both of them on top of each other. You have an absorption line at hydrogen, and then you have a re-emission line from the hydrogen atom, and here's what it looks like. The hydrogen's all fat and happy, and this energy comes up from the sun's photosphere, and it says, whoa, it absorbs it, and it blocks out that light from your eyes. It makes an absorption line. Nature comes along and says, I don't want it anymore. It re-emits it at the exact same wavelength. So when it absorbs it, the electron goes from the second energy level to the third energy level. When it re-emits it, it drops back down to the second level. So you have a black absorption line with a red re-emission line in the center of it. This is a very, very close-up view of just a tiny portion of the sun's red light in the visible spectrum. From here to here is where my telescopes look when I look at the sun. All I'm seeing is this 0.5 angstrom. Anybody know what an angstrom is? What's an angstrom?
It's like 10 to the power of minus 10.
Close. It is a very, very small measurement. Yes. It is the diameter of a hydrogen nucleus. Very small measurement. So this line, this re-emission line, is 0.5 angstroms in diameter. My telescope is designed to see only that and nothing else. So when I aim it at the sun, I don't have any darkening filters or anything. We're just getting rid of different wavelengths. We're only seeing the re-emission line. And on each side of that line is this black absorption line. There's no light there. Okay, so that's the kind of boring part of this lecture. Let's move on. What color is the sun? It's every color. The sun emits visible light in every wavelength. It also emits every other wavelength on the electromagnetic spectrum to some degree. Gamma rays all the way to radio waves. This is that hydrogen alpha. This is an actual picture from the spectroscope. This is the hydrogen alpha absorption line. The re-emission line is so small it can't be seen in this particular image. Way up there is the emission line and the absorption line created by calcium atoms, which one of my scopes also looks at. We'll explain that later. And these two lines are called the sodium doublet. Anywhere you see these lines means there's sodium. And I have a telescope that looks at the sodium doublet. The popular wavelengths for solar astronomy are hydrogen alpha, which is the line I just showed you, calcium K, which is where the other one I showed you, and visible light, which is basically in this area. Okay, and that is a Pink Floyd album. You guys have heard of Pink Floyd? This is what hydrogen alpha looks like through a telescope on a just normal day with very low activity. And again, it's produced by the electron going from the second to the third shell, causing the absorption line, and then dropping back down to the second shell, causing the re-emission line. Its wavelength is 656.28 nanometers. Bring that up at a Halloween party. This is what the hydrogen alpha line looks like with Venus in front of the sun. In 2012, there was the planet Venus transited in front of our sun. Did anybody see that? Anybody ever heard of that? This is what I'm saying, man. This is an unbelievably magnificent event that occurred in the sky, and nobody even cared. Nobody even looked at it. This happens every 117 years. And here I got a class of brilliant college students, and nobody even knows what I'm talking about. That's got to change, because the future is not down here, man. The future is up there, and you are the guys that are going to do it. Okay. Anyway, this is what the planet Venus looks like going in front of the sun, shot with the hydrogen alpha wavelength telescope. And this was taken by me on the slope of Mauna Kea in Hawaii, just below the Keck telescope, and we broadcast the Venus transit for the NASA TV channel, which some of you may have seen. But anyway, I did that with a carry-on suitcase and an 80mm telescope about this big and that MacBook. And I lashed myself to the side of the Keck telescope's observatory so I wouldn't get blown off. Because if you go to Hawaii, it's cool, but if you go 14,000 feet high in Hawaii, it's terrible. It's 80-mile-an-hour wind and below freezing temperatures. So the next one I'll talk about, the calcium K, is caused by that same light exiting the sun, entering calcium atoms. It causes it to release an electron, become ionized, and it also releases a photon at 393 nanometers. And this is what the same scene looked like in that wavelength. I wore my obligatory hoodie. I'm not a big cold girl. Planet Venus in front of the same sun at the same exact time, shot through a telescope that only sees the light emitted by calcium atoms in the sun's chromosphere. This is called calcium K. The K does not stand for potassium. Okay, the K is just the label of the wavelength. Visible light this is a rainbow of visible light. The other telescopes I use, and this is a visible light version of Venus passing in front of the sun at the same time from the same location in Hawaii on top of Mauna Kea. And this occurred on June 5th, 2012. And you might see it if you live another 114 years. You may be able to see it again. Okay? And let me tell you, all kidding aside, man, it was awesome to watch. I mean, you're looking at the sun, and the next thing you know, Venus is just black and white. It's really cool, but nobody thinks about this stuff anymore. They're too busy, where's my money?
Is this just an eclipse where the Venus is blocking the radiation?
Yes, it's called the Venus transit. It happens about every 117 years, and it's an amazing thing. But what time is Honey Boo Boo on? It seems to take. I'm not trying to jump on you. I'm trying to let you know that this stuff's out there and how amazing it is, because you're here in this super high intellectual status, going to one of the best colleges in the world because of the knowledge of these things from the past that other people acquired. You're learning that knowledge from those people. Okay? You need to add to the knowledge, not take from it and make money. Okay? You can do them both at the same time. Add to the knowledge in your lives. We'll keep going. Because I'm pretty high on my soapbox right now. I'm trying to get off. Layers of the sun, the core is where fusion takes place. Radiative zone radiates energy from the core. Convective zone, heat is released. That's what convection ovens do. The chromosphere, where my telescopes look, is right there. And this is a 5th grade diagram from the Georgia State curriculum, layers of the sun. Okay, corona, not the kind you drink. The corona goes out about 1 million miles from the sun. I said the corona goes out about 1 million miles from the sun. Okay, so what is an active region? The sun is a gigantic mass of incandescent gas. It releases all these wavelengths. It's controlled by electromagnetic forces. The magnetic field of the Earth pretty much stays like this as it rotates because we have a relatively slowly rotating core surrounded by mostly very dense liquid and a crust. The sun is all highly energized gas and plasma. So when it rotates, each latitude rotates at a different speed, just like Jupiter. That's why the clouds are so weird on Jupiter. Well, the magnetic field also rotates like that. It gets twisted up and all kind of crazy stuff happens. Every 11 years, the sun's north pole rotates all around to the south pole. And for about 3 years, everything's slow and everything's good. Then it starts rotating back around, and when it gets about halfway there, we have what's called solar maximum. And that's when the magnetic field lines are extended out greatly, and they clash with each other. If you get a similar polarity magnetic field line that hits another one, just like putting two magnets together on the north pole, you get a repulsive force. Well, on the sun, you get a solar flare. Okay, so you've ever pulled a sock out of a laundry machine and got shocked? I don't know if anybody does their own laundry. I'm kidding. I make fun of my wife because she went to the best school, one of the best schools in the world, and I went to one of the worst schools. But, and she knows nothing about astronomy, and I know nothing about being a lawyer. But you get shocked if you pull socks out. Okay? The same exact force works on the sun. When you have a gathering of those phenomena, it's called an active region, and it means magnetically active. And every picture you're going to see in the rest of this presentation almost was taken by someone 12 years or younger through my telescopes at a middle school. Just so you know. What is a solar flare? Well, I just mentioned if you have two field lines that come together, they will explode and release radiation and energy into the solar wind. That usually produces a coronal mass ejection, which also mixes into the solar wind. That comes to the Earth and gives you a wham, a big strong pulse in the solar wind. Anything can happen from aurora borealis at the polar regions to complete annihilation of all living things on the planet. Hopefully we won't go to that extreme. This is what a solar flare looks like through my telescopes as photographed by a 10-year-old. The reason I mention that is because a lot of astronomers their images, they want a big 30-point copyright on a picture of a star. I'm like, man, this is nature, dude. You should share it for free and not worry about selling copies of it. So I'm generally regarded as one of the world's best solar imagers. But people don't like it because I never put my name on anything. I never sell anything. I mean, you're supposed to give it away. I didn't make the sun. I'm taking pictures of something somebody else did. Why should I copyright it? Anyway, that's what a solar flare looks like in calcium. Spicules. All these little tiny things right here, the small ones, they're all over the surface of the sun. This is a live image of the sun. Not live, but this is an actual image of the sun. Those are called spicules. Okay, and that's what makes up the chromosphere. These things are called prominences, and that is hydrogen plasma being blown aloft and held in shape by these magnetic field lines. You just get crazy and come out of the sun. Okay, and that happens every day on the sun. This is the largest, well now it's the second largest solar prominence ever recorded by mankind. And I'm not exaggerating. And this was taken by an 8-year-old at DragonCon. You ever heard of DragonCon? Okay. I have my setup there, and kids come up and they take their own photos and stuff. And so I said, hey, check that out. She took a movie of it. And next thing you know, this picture is hanging in a Royal Observatory in Greenwich, England, because it's the largest prominence ever recorded by anyone. It's an easy hobby. Anybody in here can be doing this within a month if you're interested. There's nothing to it. This is what a prominence is. It's a cloud of material that's ejected from the sun and goes out into space. Filament, this little dark line. Tim has a solar telescope, and he's seen all these things. He's done several events with me. This is exactly the same thing as a prominence, except when you look at it from the top down, it looks dark because it's cooler than the rest of the sun. So this, if the sun rotated 90 degrees, that would be shooting off the side like that. It just looks dark against the background of the sun. Anything in astronomy, any kind of astronomy, the brighter the light, the hotter the object you're looking at. So this indicates a cooler object floating above the surface. And they call it a filament for some reason when it's on the side. What is a sunspot? Well, if I knew that, I'd probably be a tenured professor here. Nobody really knows all the details. But basically, you got a bunch of magnetic field lines, very large, that are all entering the sun's photosphere at the same point, and they're all the same polarity. And when that happens, energy can no longer transfer from one side to the other because everything in here is negative. There's no negative to positive, it's just all negative. So the energy coming out from the core of the sun exits around this spot. Okay, this is like a cork somebody stuck in the surface. These things are called penumbra, and that's where the surface is twisted down into this horrible magnetic inferno. You know, it's just it's a cork that somebody shoved into it. And these things on the side here are called granules. We'll look at that in a minute. This is an image taken of that same sunspot by a 10-year-old. The Earth is about the size of that, oh well, it's about the size of the red light that I'm shining on screen in comparison. So this sunspot is bigger than every other object in the solar system put together. That's pretty big. This is a movie that I did not take. This is from a Swedish telescope. These are images that I did take of granules. Anybody ever had ramen noodles? They still eat that in college? Anybody ever boiled water before and looked at it? Same exact thing is happening. Heat from the flame on your stove is convecting itself through the water and pushing up the surface to release the heat, and then the water falls back down. That's exactly what's happening here on the surface of the sun. These granules, these pelagonal granules, are all 500 to 600 miles in diameter, and they last about 3 or 4 minutes. And with a decent telescope, you can just watch them boil. You know, it's cool. Does anyone here have a solar telescope or ever looked through a solar telescope? You had to look through a solar telescope? Was it mine? Someone else?
I was a child.
A child. Yeah, that's a shame. Because I was going to bring my scopes out and set them up for you outside, but we couldn't work out the logistics. Plage. Anybody speak French? What does plage mean in French? Beach. Exactly. Plage means beach. So early astronomers saw these things on the surface of the sun and didn't call them beaches because they look like beaches. But that's actually, remember I told you the sunspot blocks the energy release from the core? When it goes out around the sunspot, it's more highly energized because it's been diverted. So that's what it looks like there. I call it plage. Coronal Hole. There was a dude on Fox News last year who was the editor of Discovery Magazine, Corey Powell, who's got a PhD in astrophysics, and I know, I've spoken to him. He gets on Fox News and says, a chunk of the sun is missing and heading right for us. This is 2 years ago. Okay? Based on a photograph similar to this from another NASA probe that has been decommissioned. That's how little people know. Even a dude with 2 doctorates doesn't even know what he's talking about. Who runs a science magazine. Okay? This indicates cool temperature. The corona is a mass of gas around the sun. It's generally hot. Sometimes you get similar polarity field lines again that cool off a certain region. That's called a coronal hole. And we have one right now that's about this big facing the Earth. And what happens there is the solar wind escapes the surface a lot faster. So it also puts a pulse into the solar wind. The solar wind is usually about 300 kilometers per second hitting the Earth's magnetic field. When you have a big coronal hole, it can go up to 1,200 to 1,500 kilometers per second, which has a big impact on our upper atmosphere. And it causes a lot of problems with navigation, etc. So that's what a coronal hole is. It is not a chunk of the sun heading like that. There's the solar wind coming out of the sun. This is a NASA animation. And you evolved in this. I'm hoping you guys have gotten to this point, but everybody in this room is identical as far as science is concerned. There's, you know, we all are Earthlings, and we evolved from this planet in this solar wind. Okay. The reason your eyes, this is a side note, but you're not as sensitive to red as you are to green and yellow. Anybody know why? Well, because the sun emits 80% of its energy in green and yellow. And you evolved on this planet to avoid predators. And the way to avoid predators is to be able to see them. So if you can't see green or yellow on this planet, you will be eaten quickly. So your eyes contain a fingerprint of the star around which your species evolved. So if you have an alien, like I thought my ex-wife was an alien, but I just have sensitivity to green and yellow. If you meet an alien, or whatever, they're probably not going to be sensitive to the same wavelengths you are. Because, yes, our sun is an average yellow star, but if they came from Betelgeuse, for instance, which is a red giant, they would not have survived long without being extremely sensitive to red light. You understand? You carry your fingerprint of your origin right here. And as far as what country you're from, that's irrelevant, man. I mean, it's Earth. That's where you live. Okay, so there's the auroras that happen when the solar wind strikes the Earth's magnetic field. We got to move along, don't we? All right. That's an aurora picture I took from Edmonton, Canada last year, and that's just what they look like with an iPhone. Anybody ever seen the auroras in person? You have? In Norway? Iceland. They're a lot stronger in Iceland. This is what I took. It's another picture I took. I just thought it was unbelievable, you know. And they waft. I can tell you, they waft in the sky. They just move around. It's like someone has a bunch of chiffon hanging from a curtain rod, very light hand. Just there's this. It's really cool, especially like if you're on a date or something. I mean, that's the perfect setup. This, boom, was taken from Iceland 3 days ago. Because I told you we had that big coronal hole facing us right now from the sun. And this is the aurora that are getting in Iceland. This is a 2-second exposure. Okay? And that's all over the place in the northern latitudes right now and the southern latitudes. I spent several months in Australia last year also teaching this program, and you saw auroras every night. You know, it's nothing new. Coronal mass ejection again. The sun's over here in this diagram, the Earth's over here. All this medium gray stuff is solar wind, all this stuff here. But when the sun ejects a portion of its corona, which happens 3 to 5 times a day during solar maximum, a couple times a week at solar minimum, that's what it looks like. Boom. There was a big event called the Carrington Event in 1859. I don't know if anybody's ever heard of that, but that's kind of the father of solar astronomy. And it burned up telegraph wires, and all kind of crazy things happened. They could see auroras at night all over the world. This event on Halloween, or near Halloween 2003, was just as strong, if not stronger, than the Carrington Event. It's just that it was aimed away from the Earth, so that's why we're still alive. But that's what they look like. The corona is very, very, very low density. It's like cigarette smoke almost, or even lighter density. But it's held magnetically together around the sun. It goes out about 1 million miles. And whenever there's a significant event on the surface or the chromosphere of the sun, a big chunk of the corona will just say, screw it, blow out of this place. It happens all the time. If it's aimed at us, there could be problems. That's what they look like. This is a little diagram of one that happened July 23rd, 2012. And I was watching this with a group of middle schoolers. The one that came off the right there, we'll watch it several times. There's the sun, there's the Earth, there's Mercury. So there's a pretty moderate CME that came off of the sun right there. Everybody's like, wow, that was cool. And then right after that, boom, that one came off, which would have destroyed the planet. It ended civilization. Had it been aimed at us. At a minimum, it would have removed electricity from the entire planet for months. Anybody here think they can live without electricity in 30 days? Anybody from a country where they did live without electricity in 30 days? You would all be dead within about 20, maybe 10, 15 days. Maybe me and this old guy here would survive for a little while, but the rest of you, hopeless. Water, food, internet, video games, making transactions. Everything in our lives now is controlled by signals back and forth to satellites in our atmosphere, everything. So unless you've got some survival training for the military, you ain't gonna make it more than about 5 or 6 days. And do you really want to make it with the people that are prepared, you know, the preppers? You really want to survive a catastrophe where the only people left on Earth are dudes in their backyard doomsday bunkers? Beans and 9mm? No, man, I'd rather die. So here's a close-up of that same event. That was a pretty moderate CME, except this is what's going on above your head all the time. Okay? Yeah, this makes you a problem of, you know, I got a new zit on my forehead. Oh no, it makes that seem pretty irrelevant. All right, we won't go through it. NOAA has various levels of storm. This is for aviation lectures. Imaging the sun. This is my driveway in Virginia Highlands where I live. These are my personal telescopes. I take several telescopes to schools 3 or 4 days a week in Georgia and the Southeast. And I set up these scopes, and I bring out these little knuckleheads in middle school, and they're just empty buckets, man. Whatever you pour in that head is going to stay there and direct their life for the rest of their life. That's the way it is. So you can sit around and let them get a bunch of religious stuff or political stuff, and then you can have a bunch of radicals and extremists. You know, and who's from Georgia here? Okay. going to brag Georgia a little bit, you cool with that?
Yeah, it's pretty cool.
You can have what we have now in the country in Georgia, a bunch of, teabagging hillbillies with rifles, or you can load them up with, I don't work here, so I can say what I want. Or you can load them up with some knowledge, man, some art, some science, some math, anything. Ignoring them is not an option. And I go to these schools every day, and I'm telling you right now, I'm being ignored. The math we teach is from anyone from China. Went to school in China, anybody? When do you take calculus? China, 5th grade, 6th grade, or something?
Elementary school.
Elementary school. Wow. We don't even teach calculus anymore in the state of Georgia in high school. Okay? It's an honors-only class, and you might have it at the best schools. They don't even teach it. Okay, I was in Tunisia last year for a while. Islamic country, friendliest people on earth, by the way. They're taking calculus in 4th and 5th grade. It's pathetic, man. You're not going to be able to Kardashian your way to a better future. Okay? I think that your looks and your sense of humor are going to make you successful in life. You're wrong. Your education here is what makes you successful. If you happen to be beautiful too, that's great. But man, the streets are full of people that are good looking and dumb. Okay? All right. So we set up these imaging stations, visual stations for people to look at the sun. These are all before and after pictures here of the sun taken by students. This is a sunspot, that's a solar flare at the same spot, and this up here are clouds. Somebody asked me if that was smoke from a solar flare. No, it doesn't produce any smoke. This is the same sunspot group in all 3 wavelengths that I teach. With the plage, this is a solar flare, you can see it a little bit here. And this is the white light view with no indication of it. This is a movie of an actual X-class solar flare, which is the strongest class. You have C, M, and X. This flare, the white area, is 2 million degree plus hot plasma that was ejected from this sunspot because of magnetic field interaction. And this happened in about 4 minutes. It lasted about 15 minutes, and then it went away. That is a major, major catastrophe if you happen to be near it. Okay? The Earth, again, is about the size of my laser pointer. That's the kind of stuff that goes on the sun. This is another flare taken by students in several different wavelengths. And this stuff is very easy to do. Anybody in this room can be taking these pictures within 4 hours with me. If I took you outside, there's nothing to it. It's a great hobby. Sun, calcium K. There's the sun in the hydrogen alpha wavelength with some prominences coming off the sides. This is the pretty picture portion of the lecture. Prominences, this is the sun's calcium ions emitting light. This is natural light from the sun. Massive sunspots. These are all taken within the last few months. Another hydrogen alpha image. That's me and my telescopes in front of the Space Shuttle Atlantis and Discovery when they dedicated it, put it in the Udvar Hazy building in Washington, D.C. We went out there and did that. Anybody know what that is? Huh?
Satellite?
Yeah, not just any satellite. That is the International Space Station flying by the sun. And when you're a little kid in middle school and you see that, it's going to make a memory. There's a close-up of it. Space station containing 9 astronauts. Just flying in between my telescope and the sun. You know, the space station is about 240 miles above the Earth's surface. It wasn't at the sun, but it just flew in front of the sun. There's a giant prominence that's about to erupt, or filament that's about to erupt off the sun. This is the world's largest prominence ever recorded. Remember that last one was the second largest. I took this one about 2 months ago. This is the largest solar prominence ever recorded by mankind. That's the size of the sun. And it was so large that I couldn't get the sun in the same frame. That's how big it is. And I watched this for over 12 hours just float out there about 2 million miles off the sun. It just kind of floated. Man, there's some cool stuff going on in space, okay? So just take a look at it, yes?
So is that just gas or is that a plasma?
And highly energized plasma, because remember purple is much higher energy than red because of blood spectrum. So it's highly energized plasma. There's probably no solid matter at all. There's, kept going. finally got out to this length, 1.5 million miles. Now just take a through a backyard telescope. My drive. Accident. I didn't even know it was there. I didn't do that, man. Hey, come here, wife, do that. She goes, I'm busy. There you go. Charlie Bates Solar Shrine Project is named in memoriam for a guy I served in the military with. Sorry. Tim, this is all your fault.
Yep.
A guy I served in the military with, Charlie Bates, and he committed suicide in 2008 after, veterans do it. Anybody here in the military now? There's a high suicide rate among veterans. So I decided to name my program after him, so that he would be remembered. That's what people used to do before it was all about me. It used to be all about other people. And what we do, well, let me see a little bit. This is live internet sun that you can find on the internet anytime you want to. I'm going to skip this portion. There's a film of the sun from NASA satellites. These are all the different flares that went off in a 1 year period as viewed by NASA SDO. Yeah, there you go. So what I do when after he died, I was driving a $140,000 Porsche at the time. I was thin, I had hair, I was single. I was a self-absorbed prick, basically. I decided that I was going to take all this and try to do something good instead of just spending money on useless stuff. So I started this nonprofit foundation and took all the money I'd saved from air traffic control and invested in solar telescopes and equipment to teach kids about science. That's how the program started. The Starbucks in Little Five Points was the first place I set up a telescope. And a bunch of teachers came by and said, "Hey man, can you bring that to my school?" I said, "Yeah." And that was in 2008. And that first year, we saw about 40,000 kids just in Georgia. The next year, my nonprofit started to get noticed because I got several pictures published in National Geographic and Astronomy magazine, just stuff like that. And a guy called me and said, "Hey man, come on to New York and do this big TED Talk and this lecture and stuff." I'm like, "Yeah, okay." So I started getting noticed. People started giving me telescopes to use in my program. These vendors wanted to be part of it because people started knowing who I was. So I started giving away stuff. Anytime I got a new telescope, I took the other one and gave it to somebody. And I'd get on Facebook and just try to find somebody who was teaching kids science in some other country and say, "Hey man, you want this telescope?" And I just shipped it to them. And that's the way it started. And that took us into 27 different countries. And it's really, really expanded way bigger than I ever thought it would. So I'm real humbled and real proud of that, but I'm also a little humbled by it because now I got to maintain a program in 27 countries. I got to ship stuff all over the place all the time. But the point of all this is that one person with just average assets, like you, can easily do something that changes a small part of the world for good. Okay? Anybody can do it. So people always come up and say, "Man, I love what you're doing. This is great, this is great." And I always look at them like, "Well, why aren't you doing something?" Because when you educate students, and young students in our society, you benefit because you live in this society. You don't have a bunch of people hiding from each other. Everybody hates everybody else for whatever reason. Everybody's got to have a gun in this country, because those people want to kill me. I need a gun. You don't need a gun, man. There's nobody out there trying to kill you. Just walk around and enjoy life. Okay? That's all just media-generated bullshit. So the point here is just, get out of that mode. And I'm assuming most of you aren't in that mode. And again, this lecture is for normal audiences that I see. The media is nuts. In every other country I've ever been to, they say the same thing about whatever problems they have in that country. And they all think we're nuts. So when they're telling you, "Yeah, those Syrians they're crazy, man." Well, the media over there is saying, "Yeah, those Americans, they're crazy." It's all just media-generated hype. Sure, there's some problems in the world, minor problems, most of which are religious-based. But it's not enough for you to hide out in your house and be scared to go outside. And getting this science out to middle schoolers around the world has made it a lot more easy for them to accept that fact and not become radicalized. So I look at these people that say, "You're doing a great job," and I'm saying, "Well, why aren't you doing the same thing?" Because our future depends on it. So here's some kids enjoying the program. I'll get through this real quick. It's a spectroscope we use. This is a Georgia Tech event. And there's a lot more to this lecture, but I'm going to cut it short in case anybody has any questions. But that's our philosophy. Whether you agree with it or not, it's cool with me. I don't care what your views are. You know, that's cool, man. I leave everybody alone. This is what my views are, and it's been very successful. No politics or religion. It is a waste of time. Has anyone in here ever heard a conversation where anybody ever changed their mind about politics or religion? No. So why are you talking about it? Who cares? Just believe what you want. Who cares? Egos. America's famous for its enormous egos. They are of no use. Nobody gets paid anything in my program. Free sharing of images. Give away stuff you're not using. Why do you have a garage with 4 high-end mountain bikes in it that you never ride? Give it up on the way, man. My telescopes. Yeah, I could have a garage with $1 million worth of telescopes right now if I ordered every $1 million worth of telescope. Well, what am I going to do? If you get something new, just give it to somebody else. I know I'm a socialist. I'll tell you, I make Bernie Sanders look like Dick Cheney. But people like to argue in the United States about astronomy clubs. I don't have anything to do with astronomy clubs. I just do my own thing. International Sunday every year on the summer solstice. We do a big event around the world. And if you guys are interested, and I know a lot of you are from other countries, if you want to be involved in this, I'll just give you a bunch of glasses, man, and you take them back with you. And if you go visit your friends in summer world, just give them away and just watch the books on people's faces. International Sunday is an event where I try to get everybody I can possibly get to at least look at the sun and realize it's there. Okay. This is my shameless plug. We're giving away a big, nice telescope on Facebook. Everything I do is on Facebook. The Charlie Bates Solar Astronomy Project. I know you guys are too cool to be on Facebook anymore. The Charlie Bates Solar Astronomy Project has a page on Facebook. We're raffling off a big telescope. That's how we fund this program. I don't care if you donate or not. But just know that it's there, and if you want to get involved, I will give you what you need to become a solar astronomer and an outreach person. Okay, I will help you do that. I know you have nothing else to worry about right now, being in college, right? You have nothing but free time. But that's what we're doing now. You think that's Photoshop or real? It's real. Anybody from Australia? This is a sunset from the Australian Outback where I taught solar astronomy last summer. How many days have you went through your entire life and never looked up? Make it a point, especially tomorrow morning, for instance, if you get up before the sunrise. If you just look east all this past week, you will see Mercury on the horizon, same place where the sun's going to rise later. You'll see Mercury, Jupiter, Mars, and Venus, all in a straight line right there on the east at sunrise right now. So tomorrow morning, if you can get your ass up there, and you go look up, you will see, it'll be the only thing over there. It's the brightest things in the sky. You'll see all those things for free. Okay. So does anybody have any questions about what I was telling you about? I appreciate you listening to me. I know it's not an average college curriculum. I hope you got something out of it. I appreciate you listening. I have on the table solar glasses that I distribute all over the world. You're welcome to take as many as you like. There's 100 pair here. These are really cool. Just put them on and look up. I also have, this is the other thing I give away to all the students. This is a diffraction grading. Any light source you look at with this, it will show you its spectrum. Okay? You can look at anything. If you look at the sun with it, don't look directly at the sun. Just look near it, and you'll see the spectrum. And these will be down here also as you read these classes. I got 2 hats left. After hearing my extraordinarily rousing lecture about how great science is, would anyone like the other 2 hats? Okay. They'll be here, and I'm glad to give them to you. 3 hats, actually. Well, that's it.